Hi everybody and welcome back. Today we're going to be starting a new chapter, and the first section is working with rational expressions. So we're looking at, in this chapter, we're looking at simplifying expressions that are rational. So big thing here is that we have a couple of prerequisite skills that you're going to really need to understand, and the first one is simplifying rationals or fractions. And what I'm talking about here is understanding when you can simplify something and when you cannot simplify something. Okay. Another skill it's going to be using is factoring, and you're also going to need to know how to factor through decomposition for some of the questions. So I'll try and talk a little bit about those as we're going through the video, but if you're unsure or if they sound a little bit foreign to you right now, you might want to go back and brush up on some of those skills, and I can certainly help you with that in class. So some of our objectives is we need to determine a non-permissible value for a rational expression, and then we're also looking at simplifying rational expressions. So first we need to understand that a rational expression is just an algebraic fraction that has polynomials in both the numerator and the denominators. Okay, so we're working with variables here. They're going to be of varying degrees, and it's going to be either like monomials, trinomials, or binomials. First thing that we always have to do is determine what the non-permissible values are. So in any fraction, you should know that the denominator cannot be 0. If it's 0, that means it's undefined. So we have to make sure that we determine what the non-permissible value is. So we always set the denominator equal to 0, and then we're going to isolate the variable. Similar to how you set the radicand equal to greater than or equal to 0 in the last chapter. Okay. And you need to know that when we are simplifying rational expressions, there's 3 steps. You're always going to factor the numerator and the denominator first, always. Okay, from there, you'll look at the denominator, and then you'll find your non-permissible values at that point. The reason we factor first is because some of the factors might actually factor out, which would eliminate some of those non-permissible values. So always factor first and then simplify to find your non-permissible values. Sorry, you're always going to factor first and then find the non-permissible values and then simplify. Sorry, you are not going to simplify here. So you factor, find the non-permissible values, and then you're going to simplify by dividing both the numerator and the denominator by common factors. Okay? So getting into our examples, the first example that we're going to look at is just determining the non-permissible values for these rational expressions. So here, again, we're only focusing in the denominator. So our denominator is 3 equals b, or 3bc. That cannot equal 0. So now it just becomes basically a algebraic equation. We know b cannot equal 0 and c cannot equal 0. Okay? Because all these terms are multiplied by one another, if c equals 0, that means this whole thing equals 0. If b equals 0, this whole thing equals 0. Okay, so those are the 2 restrictions on that. Here we already have a factored form in the denominator, so this time we have to consider this. We have a binomial multiplied by a binomial. Okay, neither of these individual binomials can equal 0. If this equals 0, that means the whole denominator is 0. If this equals 0, same thing. Everything would equal 0. So what we do is we take x squared and we set that it cannot equal 0. Rearrange to find that x cannot equal 2. Then we do the same thing for the other factor, which is x minus 3, and we find out that x cannot equal positive 3. Okay. For this last question here, in the denominator we have y squared minus 4. What you should notice is that is actually a difference of squares. So that's prerequisite knowledge. When you see a perfect square, which is y squared, subtract another perfect square, that's a difference of squares. And what that's going to factor to is, in order to figure out the 2 factors, we're going to take the square root of y squared and the square root of 4, And those are the two factors. So we have y squared, we take the square of that, we get y. The square of 4 is 2. Our two factors are y plus 2, and then we get y plus negative 2. That's how the difference of squares simplifies. Okay? From here, what we need to do is we need to set y plus 2 not equal to 0, solve for the restriction, which is y cannot equal negative 2. And we must do the same thing for this factor, which is y minus 2. It cannot equal 0. Therefore, y cannot equal 2. So in order to simplify, again, what we want to do is we want to factor both the numerator and the denominator to see if any factors cancel out. So that's the whole point of it, okay? But remember, you have to factor first, then you're going to state the restrictions, and then you can simplify, okay? When you're simplifying, what you have to be careful for is these opposite factors. Now, opposite factors are something that cancel out to give you negative 1. So, for example, negative 2 over 2 equals negative 1. These are opposite factors. Another example, if I can find it here, is x minus 3 over 3 minus x. Okay, when you simplify, again, you're going to get a negative 1 here. Okay, so you just have to watch out for that when you're working through your questions. So let's look at our first couple of examples. So again, we're going to simplify the following expressions. Be sure to state our non-permissible values before we cancel factors. So what I've done for this first question, both the numerator and the denominator have to be factored. So what I've done is I've broken it down into factoring the numerator first and then the denominator. So let's focus on the numerator. What you should notice in the numerator is that you've got 2y squared plus y minus 10. Right now there are no factors that can be factored out as it stands. What we need to do then is factor by decomposition. So again, this is some prerequisite knowledge here. In order to factor, we're going to take 2, multiply it by negative 10 to get negative 20. We need to figure out what two numbers multiply to negative 20 and add to 1. Okay? When we do that, we find out that it's plus 5 and minus 4. We'll substitute 5y and minus 4 in for y. Okay, this is y decomposed. We've just simply rewritten it as 5y minus y so that we can factor it. So we're going to group these first two terms together, and from those terms we can take out a y. So we're going to remove the y, leaving us with 2y plus 5y. Now our hope is that when we factor the second part by grouping them, that will end up with, sorry, this should just be 2y plus 5, not 2y plus 5y. So what we hope is that over here we end up with 2y plus 5 as well. So from here we can factor out a negative 2, and that does leave us with 2y plus 5. So that was the numerator. Okay, next we're going to work with the denominator. So in the denominator we have y squared plus 3y minus 10. And what we're asking ourselves again is what two numbers multiply to give us negative 10 and add to give us 3. So we should notice that it's y, or plus 5 and minus 2. So those are the two factors. Now that we've found our numerator and our denominator, okay, in this numerator I skipped a step again. Sorry, I'm just noticing this. Here we have 2y plus, it should have been 5y. Just going to cross that out so that we can see that this is not supposed to be there. Okay, so we should have 2y plus 5y and then another 2y plus 5y. That's one factor. Our second factor is y minus 2. So we have 2y plus 5 and then y minus 2 in the numerator. Our denominator is y plus 5 and then y minus 2. Now what we need to do is look at what our restrictions are. So again, the restrictions are only relating to the denominator. This denominator cannot equal 0. That means that this factor cannot equal 0, this factor cannot equal 0. This binomial cannot equal 0, binomial cannot equal 0. So what we need to do is set each of those equal to 0, so we'd get y plus 5 equals 0, which tells us that y cannot equal negative 5, and y minus 2 cannot equal 0 either, so y can also not equal 2. Okay, from here, now what we can do is we can simplify by crossing out our factors that are common. So we can see we have a y squared and a y squared. That is a common factor between the numerator and the denominator. We can cross it out, and our final answer is 2y plus 5 over y plus 5. Okay, again, we cannot eliminate the y here and the y here because those are not common between all the factors and all the terms in this expression. Likewise, we cannot simplify the 5 because it is not common between all of these terms. Okay, so this would be your final answer. Now, this we have 6 minus 2m and m squared minus 9. So again, we should recognize that this is called a difference of squares. So we have a perfect square, subtract a perfect square. So our numerator is going to factor, we'll remove a 2. We're left with 2 multiplied by 3 minus m. Our denominator will factor to m plus 3 and m minus 3. Now again, this is a perfect square. This is how the perfect squares factor. Next step is to state our restrictions. M plus 3 cannot equal 0. M minus 3 cannot equal 0. When we set those up, we find that m cannot equal 3 or negative 3. From there, we can then simplify. Notice that we have 3 minus m, but in the denominator we have m minus 3. Those are those opposite factors that we talked about earlier. So we can simply cross those out, and we end up with a negative 1, which when we multiply by 2 equals negative 2. This is our final answer. Okay. The last question is a little bit more difficult because we've got 2 variables in it. Okay, so we need to determine the non-permissible values, and in order to do that, we have to do it for both x and y. So let's take a look at this. So the first step is to set 8x minus 6y not equal to 0. It cannot equal 0. We move the 6y over, and this time we're setting the non-permissible value for x. So we divide by 8 over here, divide by 8 over here. X cannot equal 6 multiplied by 8. Now we need to do the same thing for y. So again, we're looking at the same equation. We're going to move the 6y over. This time we want to isolate I, so we're going to divide both sides by 6 to give us 8 over 6x cannot equal y. To go back to this original one, I didn't simplify, so it actually cannot equal 3 over 4y. Okay, we have to simplify this one, and it cannot equal 4 over 3 multiplied by x. Okay. Question B asks us to determine what the non-permissible value is for y if x is equal to negative 3. Sorry, just 3. So what we have here is, remember that y cannot equal 4 over 3x. If we're given the value of x, that means that y cannot equal 4. We substitute 3 in for x here, multiply it together, these two will cancel out, and we get 4. Okay. Now we need to evaluate the expression for x equal to 1.5 and 2.8. So we're going to simplify this first. We're not going to use a calculator and just simply substitute x in for y. We're working with simplifying these rational expressions. So what we're going to do is we're going to factor. Factoring the numerator, this is another difference of squares. We have a perfect square minus by a perfect square. Okay, so we take the square root of this term, we get 4x. Square root of the second term, we get 3y. And then our second factor is going to be those same terms separated by the opposite sign. Okay, the denominator we can factor out a 2, leaving us with 4x minus 3y, which is perfect because in the next step we can cross out a factor. So we can cross out 4x and 4x minus 3y and 4x minus 3y, leaving us with 4x plus 3y. From here, what we're going to do, oh, sorry, over 2, I forgot about the 2. 4x over 3y over 2. From here, what we can do is multiply by substituting in our values for x and y. When we simplify, we find that it equals 7.2. Okay, so this video was a little bit longer. It's a lot to take in, but hopefully you understand the importance of all that prerequisite knowledge that you're supposed to have at this point. If you are feeling like you're having trouble with factoring or understanding decomposition or recognizing difference of squares, please see me so that we can go over it and I can give you some extra couple practice questions to help hopefully refresh your memory. Okay, have a good night. We'll see you in class tomorrow.